Welcome to Lab G. As an example, I will be doing the second part, molarity and density, the sucrose problem. I will leave the Coca-Cola up to students, and we'll just do the second part of that second part on the generic cola. So I'm going to scroll down. So here it says sucrose problem. I think eLife sometimes needs a while to build this up, and as I said, the first part of this sucrose problem I'll leave up to the students, and therefore we'll continue on to the second part, which some of the calculations are really the same as in the first part, but then there is one other calculation attached to it. So this is what I will be doing. Switch to the problem description on a generic cola. Use a scale, at least 3 25 milliliters. Create cylinders. You also need sucrose and distilled water. Determine the density of the generic cola. You should know how to do that. That's all you'll do with the brownish generic cola solution. And then here's the trick. Mix a sucrose solution whose density matches the generic colas. Use the data from that new sucrose solution to compute everything. And numbers 10 and 11. And I'll scroll further down to the table that we'll be filling out. Right here, what is the density of the generic cola? That's where I'm going to start out. The procedures that I just read very quickly through, I have them lying on the side here, so I don't have to switch forth and back. On the screen, I will go over to Iridium now. Density, sucrose problem, and then of course there is the problem description, but you also have that on your lab sheet. Here's the problem description. So I also have that lying on the side, and I'm going to follow my own instructions. Switch to the problem description of generic cola. Use a scale. 3 graduated cylinders of 25 milliliters each. I just copy and paste them here with Ctrl-C and Ctrl-V. Have them available. And we need the sucrose and the distilled water. And of course we need the generic cola. Determine the density of the generic cola. Without further ado, you should know how to do that. So we'll take a scale, we take a graduated cylinder that we tear. For example, 10 milliliters of generic cola in there, because 10 milliliters sounds good. So there we go. We record that we have 10.84 grams for 10 milliliters, and that of course gives a density. It's easily calculated. Divide one by the other. That's why I chose 10 milliliters of 1.084 grams per milliliter. 1.084. It just takes me a moment to write it here on the side, so I have to switch to the Word document all the time. Then it says, here's the trick. Mix a sucrose solution whose density matches the generic colas. Use the data from that new sucrose solution to compute everything. And that's why I do the second part, because that particular procedure is sometimes confusing. Okay, go to the next one. Return to distilled water and sucrose. So this is where I'm going to do it now. Take this graduate cylinder off. Use the scale in new empty 25 milliliters graduate cylinder, in parentheses, tear it. Fill in 10 milliliters of distilled water. There it is. Add an additional 1 gram of sucrose. then repeatedly add 0.1 grams of sucrose and keep count and compute the density every time using the mass and volume shown in Iridium. You don't need to write any of these down to hand them in, just the end result. Notice that with each 0.1 gram sucrose density increases. Continue until the density is close enough to the generic clause. So I'm going to just fill in 0.1 grams here. There we go, 11.1 grams. At that point, I'm going to go here and I take 11.1 grams and divide by the volume that I find in the solution window of 10.69 milliliters, and I come out with 1.038 grams per milliliter, which does not match the generic clause density. So I fill in some more, another 0.1 grams. Now my calculation is 11.2 divided by 10.753 milliliters, 1.041. So I fill in another one. It's 11.3 divided by 10.816, and I come up with 1.044 grams per milliliter. Seems like it keeps going up by 0.003 grams per milliliter, so it'll take a while. I'll just be confident and fill a total of an extra 10.1 grams in here. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that should get me relatively close. 12.3, and I did that by looking at my numbers, 1.044, and that goes up by 0.003, so the next one would have been 4.7, then 5.0, and then 5.3, and I have to go up all the way to 8.4. So let's see where we are now. 11.443 is the volume. 10.74, relatively close. Maybe another couple of times, and let's see what I get. 12.5 divided by 11.568 milliliters, 10.80 once more. 12.6 grams divided by 11.631, and that equals 1.083 grams per milliliter for density, and I call it close enough to the 1.084 grams per milliliter for the generic Kohler. So what we have in this graduated cylinder now is the same amount of sucrose as we have in the generic cola. And we have to specify what amount means. That means mass percent is the same, the molarity is the same, molality is the same, the mole fraction is the same, and of course the density is the same, which we just determined. At that point, I will go to Word and plug in a few numbers. Notice that we put a total of 2.6 grams of sucrose in there. So I'll jot that down. And that we have a total volume of 11.631 milliliters. Now I'm going to go over to Word.